it's an amazing opportunity. You know, I feel incredibly privileged to be working on something for NASA that's going to go on the International Space Station, and I'm extremely excited.
The Hunch project is designed for high schools united with NASA to create hardware, and our objective is to create a plant experiment in order for plants to be growing and be able to be grown in outer space.
We are working to send plants up into space and have them grow there and stay alive for 6 months on the International Space Station.
It's a really exciting opportunity for us. They have a skill set that they develop through working through a lot of these problems that I can't simulate in here with a lot of the projects we have. So their learning is developed far beyond what I ever expected.
Our biggest challenge is gravity. And so how do you grow something that depends on or demands gravity in order to grow roots to grow down and the plant to grow up?
We developed a plant chamber to remove water from the roots. We named it hydrofuge. It's actually a centrifuge that spins the water off the roots.
The process is basically we get the prints from NASA, and then we have to take those prints and we have to draw the parts in the computer. And then once we have the parts drawn in the computer, we can then create tool paths that the machine is going to run around those parts.
It is a fascinating project to be working on, to get out into a real world challenge. Whether it's to grow food, whether it's to test some psychological reaction, whether it's to provide some outlet for the astronauts up on the space station. This really is an application of science to a real-world problem.
In the process of trying to figure out how we were going to do an experiment, we realized that there was nothing actually available to put the plant in. So then we started developing a chamber for the plant, and after a while that became the focus because there were a lot of issues that we had to overcome to actually make a plant survive in zero gravity.
There's no textbook. There's no chapter 27, read the chapter and answer the questions at the end. Taking all of these programs and then taking the bits of applied knowledge to work on this one project.
Like with anything else, there's a learning curve. The parts are extremely complex, so there's a lot of learning that went into that. Learning how to process the parts, how we're going to machine the parts, dealing with NASA, trying to get our problems figured out. Yeah, the whole thing's been a great learning experience.
It's been interesting. It's been a learning experience, especially again watching the students as they developed and learned how to work with NASA themselves. That was a really neat experience.
The long-term reward is to see this little box up on the space station.
My favorite part has been watching the students develop this from an idea on a piece of paper to an actual working prototype that they were able to take and then fly in zero gravity.
Prestige that you get from it is phenomenal. There's a huge piece of pride that we all have from being part of this project.
Some of the kids that are working on this today, maybe they go into college, maybe they go into a career, but many years down the road, it's possible that little seed that we planted sprouts, and all of a sudden they're a NASA technician or a NASA engineer.
We joined this and we were thinking, Hunch, work for NASA, we get to send a plant to space, sounds cool.
Started here at Warren Tech, I had no idea I'd end up working on something so high-tech for NASA.